Welcome back, GCC 130 students. Now we're ready to talk about covalent bonding. Remember, covalent bonding is when nonmetals share electrons. Now, they always share them in pairs, so when you share 2 electrons, it's called a single bond. 4 shared electrons is a double bond, and 6 shared electrons is a triple bond. Examples of covalent compounds, again, are CO2 and water, because they're non-metal compounds, elements from the right side of the table, nonmetals. Now, notice the bond length is actually less than the sum of the 2 radii due to orbital overlap. So looking at this picture here, in the black circle is a hydrogen atom with radius 1. The radius goes from the nucleus to the outermost level. Now, the chlorine atom is the green circle with radius 2. So it's a bigger atom, so it has a longer radius and it's a larger atom. Now, when H and Cl get together and share electrons, they overlap. Notice how the black and green circles overlap. The bond length is from nucleus to nucleus. So, because of the overlap, the bond length is less than R1, R2. If you look at me just a second, let's pretend this is R1 and this is R2. If I put them together, I have R1 plus R2. But if I overlap, now it's shorter than R1 plus R2. This is the orbital overlap for the 2 radii. So this is shorter than this. So a bond length is shorter than just adding R1 plus R2. All right, bond energy. Energy is required to break a bond. If I was going to break this, I'd have to put energy into it to break it, just like breaking a stick. So breaking a bond requires me to put energy into it. Energy is absorbed, and I break the bond. Now, forming a bond, however, releases energy. Energy is produced. So forming a bond actually lowers the energy. If you will imagine 2 atoms coming together, and when they bond, it lowers the energy. Where does the energy go then? It has to go somewhere, so it gets released out into the surroundings. So when we form a bond, the energy lowers and the energy is released out into the surroundings. It's produced. Look at these bottom 2 equations. The first one is breaking a bond. We have H and Cl already bonded together in the gas state. We give it some heat energy, and we can separate the H and the Cl atoms from each other. That requires energy as heat energy. We have to put energy into the HCl to pull the H and Cl's apart. So energy had to go into the HCl. Now the bottom equation is for forming a bond. We have the H and the Cl separated. Again, as the 2 atoms come closer and closer together, they get to bond, lower energy, and release that heat. So the heat comes out on the product side because it's produced. The heat is produced. The product side is the right side of that arrow. The reactant side is the left side of the arrow. Notice the heat's on different sides of the arrows. Now this brings to mind 2 words, endo and exothermic. Endothermic is heat goes into. That's when we break the bond, right? Heat has to go into the HCl to break that bond and break the H and the Cl apart. Exothermic means exiting heat. Heat comes out into the surroundings. So when we form a bond, we lower the energy and the energy comes out as heat, for example. So we release the heat, it's produced, it's exothermic. So breaking a bond is endothermic. Forming a bond is exothermic. All right. So remember, for a covalent bond, a single bond is 2 electrons being shared. A double bond is 4 electrons being shared, or 2 pairs. And a triple bond is 6 electrons being shared, or 3 pairs. Single bonds tend to be the longest and the weakest. Triple bonds are the shortest and the strongest.